Hello students, today we will be learning theorem on areas of similar triangles. So the statement is, if there are two similar triangles, then ratio of their areas is equal to ratio of the squares of the corresponding sides. Now here we have triangle ABC and triangle PQR which are similar to each other. So what is given to you is triangle ABC is similar to triangle PQR. You have to prove that ratio of their areas, that is area of triangle ABC upon area of triangle PQR, is equal to ratio of the squares of the corresponding sides. Now in the earlier part of this chapter we have already learnt about the corresponding sides. As per this figure, the corresponding sides are AB upon PQ, BC upon QR and AC upon PR. So here, since we have to show that ratio of their areas is equal to ratio of the squares of the corresponding sides, we need to prove that it is equal to AB square upon PQ square equal to BC square upon QR square is equal to AC square upon PR square. So this is what we are supposed to prove. Now to start with the proof, we need to do some construction in the figure, and the construction is draw the height of both the triangles. So let us assume AD as the height of triangle ABC and PS as height of triangle PQR. Now we have already learnt in this chapter that whenever you need to find out ratio of areas of any two triangles, it will be always equal to product of the base and its corresponding height. So now we will be using that property. So when we start with the proof, since we want to find area of triangle ABC upon area of triangle PQR, by using the property that it will be equal to the ratio of the product of the base and its corresponding height. So in triangle ABC, BC is the base and corresponding height is AD. Same way for the next triangle, QR is the base and PS is the corresponding height. So accordingly we will get the numerator as BC into AD, that is base into height, upon denominator for the next triangle is QR into PS. QR is the base and PS is the height. So this is your equation number 1. Now next we will be using the given condition. The given condition is both the triangles are similar to each other. So since two triangles are similar, we can use the property that their corresponding sides will be proportional and also their corresponding angles are congruent. So here the corresponding sides are AB upon PQ, BC upon QR and AC upon PR, because they are corresponding sides of similar triangles. So I am marking this as my equation number 2. Also we can use that corresponding angles are congruent. Now here actually all the corresponding angles, pairs of corresponding angles are congruent, but we will be using only that pair which we need for the further part of our proof. So here I am using only one angle, that is angle B, congruent to its corresponding angle is Q. So angle B is congruent to angle Q. Reason is they are corresponding angles of similar triangle. I am marking it as equation number 3. So now right now what did we get is angle B is congruent to angle Q. So if I just mark that in the figure, now look at the figure carefully. Look at triangle ABD and triangle PQS. Angle B is congruent to angle Q, you got it just now. Also angle D is congruent to angle S because each is marked as 90 degree. So since you have two conditions, we can easily prove that the two triangles are similar by AA test of similarity. So therefore you will get triangle ABD is similar to triangle PQS. Reason is AA test of similarity. So now we have got another pair of angles which are similar to each other. So from this once again we can pick out the corresponding sides. For these triangle, the corresponding sides are AB upon PQ equal to BD upon QS equal to AD upon PS. Once again, the reason is they are corresponding sides of similar triangle. I am marking it as equation number 4. So now if you observe equation number 2 and equation number 4, you can see that AB upon PQ is the common ratio, and since AB upon PQ is equal to these two and here AB upon PQ is equal to these two, we can conclude that all the ratios are equal to each other. But once again, we are not going to write all the ratios. We will be writing only that ratio which we need for the further part of the proof. So here AB upon PQ is the ratio which is connecting the two equations 2 and 4, and we will be writing some more ratios which are equal to each other. So from step number 2 and 4, you can conclude that AB upon PQ is equal to BC upon QR is equal to AD upon PS. So reason is from step number 2 and 4, and I am marking this as my equation number 5. Okay, so we got now some new pairs of corresponding sides. We are getting that these ratios are also equal to each other. Now if you just come back to equation number 1, just see equation number 1, we can separate this BC upon QR and AD upon PS. As per your step number 5, your BC upon QR is equal to AD upon PS. That means in place of AD upon PS, I can substitute BC upon QR. So that is what we are going to do next. According to step number 5, BC upon QR and AD upon PS are equal to each other. So in your equation 1, in place of AD upon PS, we will substitute BC upon QR. So that is your next step. In place of AD upon PS, just substitute BC upon QR. So you will get area of triangle ABC upon area of triangle PQR is equal to BC upon QR into the other one which was AD upon PS. Now it will be replaced once again by BC upon QR according to your equation number 5. So now you can see that the numerators both are BC into BC, which can be written as BC square upon QR square. That means you got area of triangle ABC upon area of triangle PQR is equal to BC square upon QR square. So if you come back and see what you had to prove, you had to show that it is equal to AB square upon PQ square equal to BC square upon QR square, also equal to AC square upon PR square. Now right now you got it is equal to BC square upon QR square. So you have proved one of the part. Similarly, you can show that it is also equal to AB square upon PQ square, or it is also equal to AC square upon PR square. So this is your theorem on areas of similar triangle based on your similarity chapter.